In this lecture, we'll discuss about parallel in serial out shift register. See here we are giving data this one, this one, this one, this one, data at a time parallelly, input data. And here at this flip-flop we are taking output bit by bit serially. So parallel in serial out shift register. Okay. Here I used pause to clock to all flip-flops and pause to reset to all flip-flops. And along with this clock or reset data input and data output, I need another input that is called mode input. Okay. So initially I have to apply parallel data, that is called parallel loading. For loading data, this mode should be 0. Then after loading I will change the mode value. To shift the data I will change this mode value to 1. Okay. And here we can see I used 4 D flip-flops, and along with the D flip-flops, because this is a 4-bit register, that's why I used 4. Along with 4 D flip-flops I need 1 NOT gate and 3 nothing but n minus 1 and or arrays. These 3 gates together one array. Each array contain 2 input AND gates and 1 input OR gate. Okay, right. So we have to understand the enable disable operation of this AND gate and this OR gate also. Here I taken 2 input AND gate, truth table. This is the data input, this is the control input, and this is the data input, and this is the data output. When this control input is 0, this B is not going to output. We are getting 0. If this B is not going, and if we getting some fixed 0 or 1 1, 0 0 or 1 1, that is called disable. So AND gate become disable when control input is 0, and when control input is 1, this B exactly going to output. So data input going to data output. So when data input directly or its complement going to output, then it's called enable condition. So AND gate becoming enable when control input is 1. This is the 2 input OR gate truth table. The output is when any input is 1, then output become 1. So it is becoming enable when control input is 0, and it is becoming disable when control input is 1. Okay. So initially this data directly going to flip-flop, but these remaining bits not going directly, they are going through gates. Okay. So sending this data through these gates is called, through these gates to flip-flop, it is called loading, parallel in or parallel loading. Okay. And here you can observe this mode value, one time it will be 0 and another time it will be 1. Initially I have to load the data, so initially it should be 0. Then after loading data I will change it to 1. Okay. So initially to load this data, this is the data input and this is the control input. Here I should get 1 control input. If I should get 1 here, mode should be 0. So that's why initially for loading mode value should be 0. At that time when mode is 0, this second gate, fourth gate, sixth gate become enable and 1 3 5 become disable. And when I change this mode value to 1, second gate, fourth gate, sixth gate become disable and 1 3 5 become enable. Okay. This seventh gate, whenever both any one input or both inputs are 1, then it will produce 1 at the output. Okay. Now we'll see the working. See this table here, I taken clock and mode, and these are the outputs of each flip-flop. See here, this is D1 Q1. I wrote Q1 here. Okay. So initially I have not applied any clock and mode is nothing, and at that time my outputs of each flip-flop is all zeros. This parallel in serial out shift register also need n clock pulses for complete working. Out of n clock pulses, first clock pulse is for loading the data, and remaining 3 clock pulses nothing but n minus 1 clock pulses are for shifting the data. Okay. So here I am applying my input parallelly. So this is not the input, these are the mode values. This is my input. 1 1 1 0. I am applying my parallel data here. Okay, so this is at clock pulse 1 my data is loading, parallelly loaded, and from second clock pulse onward data will shift. So this Q4 will come here, this Q3 will come here, this Q2 will come here. Okay, and at the third clock pulse this Q3 will come here. Okay, and this one will come here, Q2 will come here, and at fourth clock pulse this Q2 will come to Q1, and finally you can see this data what I applied 1110. From down you can see 1110 down to up. Okay, this one is coming here. Okay, parallelly I applied, and here I will get data bit by bit, serially I will get this output. Okay, in this circuit we can see how this loading happening and shifting happening. So initially this data, this bit is directly going, but this bit initially to send this bit, this gate should enable. At that time mode is 0, so here it will get 1, so this data will go out, and this data will come to here, and this data also will come to here. Now I will change this mode value. Now second 4 6 become disable, and 1 3 5 become enable. This D will come out here and it will go, and this control input is 1 because I changed it to mode 1. Now this data will come out here. Already second gate, fourth gate, sixth gate output already came. Now because of changing mode to 1, we will get first gate, third gate and fifth gate output also. And now this OR gate will compare both inputs, and if any one input is 1, it will produce output 1. If both are zeros, then output will be 0. Like that each flip-flop is getting input. Okay, so this data is coming here and coming here, and this data also coming here, this is coming here, and this is going like this. Again this data coming, and this data coming here and going like this, and this data and this data coming here and coming here, and bit is coming out like this. So this is the working. Okay.